Hi guys, today we are going to talk about 7.5 and we are going to be focusing on scale drawings. Our I can statement, I can use scale drawings to find actual distances, find scale factors, use scale drawings to find actual perimeters and areas, and recreate scale drawings at a different scale. A scale drawing is a proportional, two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of the object. So most of us know drawings are going to be on a paper or some kind of sketch pad. A model is going to be a 3D, three-dimensional actual figure of the object. So some of us have made volcanoes before. Well, when we talk about volcanoes in a classroom or even the solar system in a classroom, we can't bring the real life objects to our classroom. So we have to scale them down to bring them in and talk about them. So we use a model that is proportional. So it's a smaller version of the object, but it is proportional to the large item. So like the universe or like the planets or a volcano. Scale. Scale, it is the measurements in a scale drawing and models are proportional to the measurements of the actual object. So we've talked about proportions back in chapter 5. Proportions, we want to keep the ratios similar. We can increase them 2 times or 3 times or 15 times if we need to, or decrease them at that same rate. So scale drawings and scale models are held proportional to the actual object. All right, a scale. Scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. So if we are looking at our scale, we have the model is going to be compared to the actual. When we have a model of something, you could have a model is going to be represented with 1 inch, where the actual distance on a map or on some kind of a drawing, it could be, if there's a map, it could be 10, sorry, not minutes, 10 miles. Okay. Do that correctly. All right. So the inches is referring to, if this was your drawing model or your 3D model, this is the drawing distance. And that is going to be over the actual distance. That is this one. Okay, so let's take a look at our first example. We have a map of Michigan, and we are going to find the distances from 2 cities. So we're going to look at Detroit and Cadillac. So Cadillac is here. Detroit is here. So you're going to need to take your ruler and line it up and find out the actual distance from the map, or the drawing distance from the map of that location. Now, the scale of our map is 1 centimeter to 50 miles. So I'm going to set up that ratio. You're going to have to pause the video and actually check it to see the distance. So I have 1 centimeter compared to 50 miles in real life. When I set that up, whatever I get from this distance to Detroit, from Cadillac to Detroit, is going to go right here. Then I'm going to look for my actual distance. Okay, you can use your cross products, you can use multiplication or division to find out what your missing value is. Okay, go ahead and pause the video and you can finish example 1, and you can do it your first try on your own, because you're trying your own, you're looking at the same map, but this time you're going from Traverse City to Marquette. Now, this one, I just want to point out, you are not having to do the road distance because you would have to go around. It's going to make a lot longer. So what you are going to do is you are just going to show from the 2 points, if there was a road that went right through, you are just going to show this distance here. Okay? So the shortest point between two distances is a straight line. So that's what we're going to be measuring in this instance. Okay, go ahead and pause the video and try those two. Okay, let's look at example 2, finding a distance in a model. So we are talking about the outer core of the Earth, the liquid outer core. The liquid outer core is 2,300 kilometers or 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch, is representing 500 kilometers. How thick is the liquid outer core of the model? So as we're making this, if this is the actual thickness of that layer, and this is our ratio, what is the actual thickness that we're going to have to use when we create our model? That's what we're looking for. So the first thing I'm going to do is I'm going to set up my ratio, 1 inch to 500 kilometers. Remember, when we're setting up our ratio, we don't want to use our colons anymore, especially while trying to do our proportions. We want to set up fractions. So on this one, I have 2,300 kilometers. Well, I'm not going to put that next to inches because remember, this is our model piece compared to actual. Okay, so the actual thickness of the liquid outer core of the Earth is 2,300 kilometers. And I'm always going to put my units on here because I want to make sure I put them in the right locations. Then I'm going to solve for my variable x. I can use some cross products. So I can get 2,300 equals 500x. Then I can divide by 500. And x should equal 4.6 inches. Remember, because this is our model, that's where it should go, is up next to our model location, and those are measured in inches. Okay, go ahead and pause the video and try number 2 on your own. All right, we are going to look at scale factor. So we're talking about scale. Scale is going to be that comparison between two different units. Scale factor is slightly different, but scale factor, it's a scale that can be written without units because the units are the same. So when we talk about this, we might be talking about something in inches. That would be referring to both items being measured in inches. All right, so let's take a second and look at example 3, finding a scale factor. A scale model of a monument is 10 inches tall. The actual monument is 100 feet tall. So first we're going to look for the scale. Remember, scale, we're able to have those two different units. We're just going to compare them. I want to put them in simplest form if possible. So I'm going to compare the model to actual. It's pretty sloppy. Okay, so I'm comparing the model to the actual. So I'm going to have 10 inches, because that's on my model, to 100 feet. Well, both of those can be divided by 10. So I'm going to end up with 1 inch on my model is representing 10 feet in real life. Okay, the next question is talking about scale factor. Scale factor is that one we just talked about. So this is when we can have no units written, and that means that the units are the same. Okay, that's the only time we would ever have that case where we don't have those units compared. So in this case, I'm going to have 1 inch still. 1 inch is representing 10 feet. Okay, that's what we started with. I want to convert my 10 feet into inches. Well, I know 1 foot equals 12 inches. Okay, so from here, I need to multiply the bottom by 12 because I'm just converting it from feet to inches. So 1 inch now is going to represent 120 inches in real life. So my scale factor for this monument would be 1 to 120. And that's what I can leave it at. I don't have to have units for this one because I'm representing 1 of something equals 120 of something else. All right, go ahead and pause the video. And now you're going to be converting the drawing, or it has a drawing of 1 millimeter to 20 centimeters. Just as a reminder, 1 centimeter has 10 millimeters. So 1 centimeter equals 10 millimeters. That could help you when you're trying to convert to get to scale factor. All right, go ahead and pause the video. All right, let's take a look at example 4. We have a scale drawing of a computer chip. It's going to help us actually see the components inside the chip that has been created. So one of the things that we need to do is find the perimeter and area of the computer chip in the scale drawing. Okay, so that's this actual image right here. I highly suggest that you pause the video and go ahead and take those measurements. We're going to use my measurements as a practice, but yours may be different. As copies are made, things tend to shrink or get enlarged. So you may want to check your drawing and actually make sure that the image lengths are still the same. But we're going to work on perimeter. One thing that we have to remember about perimeter is that perimeter is all the way around the image. Okay, so it's taking this side and adding it to this side and adding it to this side and adding it to this side. Adding all of those sides together, that's going to give us our perimeter. Okay, so perimeter, when I measured, I had 4.3 centimeters. So I'm just going to put this over here. Let's try that again. So 4.3 centimeters is what I measured. I measured 4.3 here as well. So my perimeter is going to be 4.3 plus 4.3 plus 4.3 plus 4.3. Now, much quicker way, I could do 4.3 times 4. That's going to give me 17.2 centimeters for the perimeter of my scale drawing. Area. Area, we are going to multiply. So let's put this here. Try it in different colors so we can keep them separate. So area, we are going to multiply one length times the other. So length times width. So area for our scale drawing would be 4.3 times 4.3. When I multiply those together, I get 18.49 centimeters, but area, we have units squared. All right, so now we need to find the area and perimeter of the computer chip, the actual size. So remember, this one has been blown up, so we can actually look at it in a larger version. We are going to find the smaller version. So our numbers in this next one are going to be smaller than what we had. And your numbers may be slightly different if you had maybe 4.2 as your measurement or 4.4 as your measurement. So my numbers may not match exactly, but check yours. Take the extra couple seconds to measure your computer chip to make sure that your numbers are accurate. All right, find the actual perimeter and the actual area of the computer chip. So over here, it gives us a scale. We have 1 centimeter. Remember, this is the model. So 1 centimeter on the model is representing 2 millimeters of the actual thing. So model over actual. So I have 1 centimeter to 2 millimeters. So let's start with perimeter. Perimeter, I'm going to put 17.2 centimeters. Actually, let's do area since I'm still in the same color. Let's do 18.49 centimeters squared. Okay, so we're keeping that there. Sorry, we actually have to backtrack. I misspoke again. So let's get rid of this. we need to find what my 4.3 centimeter side length is as a millimeter. I'm so sorry about that. So we take our 1 centimeter, we're going to convert our 4.3 centimeter piece into the millimeter portion. So when I get this, I'm going to do cross products. So I should get x equals 8.6, and that should be representing my millimeters. So that means one side length is 8.6 millimeters. Okay, and yours may be slightly different if you had different numbers that you were using. So instead of my 4.3, you're going to use your number, whatever it was here. Okay, from here now, I'm going to change and find my perimeter and area. So perimeter we had in green. So perimeter, I'm going to take my 8.6 millimeters and multiply it by the 4 sides. That gives me 34.4 millimeters. My area, I would take my 8.6 side length and multiply it by the other side length, and I get 73.96. That's millimeters squared. Okay. All right, so let's look at letter C. We are going to compare the ratios. So the drawing perimeter to the actual perimeter and drawing area to actual area to the scale factor. So we're going to create a scale factor for these. So one thing that we have to remember about using centimeters is 1 centimeter. Let's see if I can write this. 1 centimeter equals 10 millimeters. So when we get to a scale factor, we're going to have no units. So we want to make sure that we're converting everything to the same unit. So our scale factor for 1 centimeter to 2 millimeters from the picture above. So right here, our scale factor, our scale is 1 centimeter equals 2 millimeters. Let's get rid of that. So this is just our scale. So we have 1 centimeter equals 2 millimeters. There we go. Now I'm going to convert centimeters to millimeters. So I have 10 millimeters to 2 millimeters. And I can reduce that, and I get a ratio of 5 to 1. Okay. Now I'm going to compare the drawing perimeter and the actual perimeter, and the drawing area and the actual area. So if we take a look at our perimeter, so the drawing perimeter, so I'm going to put drawing perimeter compared to the actual, so I know what I'm actually talking about for this one and where my work is located. So the drawing perimeter and the actual area, let's try actual perimeter, sorry about that. We are going to have 17.2 centimeters compared to 34.4 millimeters. Remember, 1 centimeter equals 2 millimeters in the comparison. So I was able to reduce that down. Remember, 10 millimeters is 1 centimeter. So it's a millimeter over 2 millimeters that I have here. So my drawing perimeter compared to my actual perimeter is still a ratio of 5 to 1. Okay, let's look at our area. So the drawing area compared to the actual area, we're going to do the same type of thing. We're going to do 18.49 centimeters squared compared to 73.96 millimeters squared. I'm able to reduce these down, so I have 1 centimeter squared for every 2 centimeters squared. Okay, and when I actually square this, okay, let's see if I have some space. Might have to move over to the side. So 1 centimeter to 1 millimeter, that is going to be squared. Okay, so that should still give me, right, I'm able to go from 1 centimeter, so it should be 4 centimeters. Man, messing up all over today on this. This should be millimeters. So I have 1 centimeter to 1 millimeter squared, so I'm able to undo that. And because 1 centimeter equals 10 millimeters, right? 1 centimeter equals 10 millimeters. I'm still going to have a 10 to 1, or this is 2 because this was 4 over there. My goodness. This is a 2. So I'm still going to have a 10 to 2, which reduces down to a 5 to 1 ratio. All right, go ahead and pause the video and try the last try on your own.